populations that have a hardiness zone of 6 and putting it right next to it. You guys following what's happening? The standard error for, here's the mean for zone 8 point populations, here's the standard error. You have to put them next to each other.
Going too fast for you. Shh. Boom. Yeah.
And then we can delete all the standard errors.
Boom. One more. Boom.
Steve, you trying to work on this together later, dude?
I have to write research papers still.
So don't. Wait, what?
Dude, I'm deep on the struggle bus. Like I'm in the back seats.
Why?
They're not letting me off for a while. My stop doesn't come until.
Alright,
Why?
I got a lot to do.
so anytime you have a
Bio and
decimal,
chem
you need to
labs.
fill that in with a
So I have
zero,
book tomorrow.
because it can't
English
recognize
research
that.
paper. Religion exam Wednesday. About to be a wild night, man.
And then we can make our graph.
Wise man what
So
says.
we have hardiness
chem
zone,
pre-lab to do.
acyanogenic, and
Must be
cyanogenic.
nice.
That's what we need.
That's my lab
So
report
to
for it,
make
too.
a graph in
I see the
Excel,
chem lab
you go
report
to Insert,
and pre-lab.
and then Column.
Oh, yeah, I do
This
that
is the
too,
clustered
yeah,
bar chart, the two that are
Aside from
together.
Oh, and two sources.
You right click on the little box that pops open
What
and
paper?
you select data.
The chem
We want to
lab
add a
paper.
series. We're
I
going
think we
to
have
do
to do
percent acyanogenic first. That's the series name. The series values, you click on this little box and you drag down over the values. And we got one done.
Now that.
Now we add a series. The next series name is percent cyanogenic. The series values are below it.
Get ready. Drum roll.
Now we need to give the horizontal axes the right numbers. Look what's here. Are these the right numbers?
Mm-mm.
What should
No way.
be here?
3, 5,
Hardiness
6,
zone.
7.
So, let me back up so you know what I did. Come here to horizontal category axis, go to edit. It says axes label range, so now you can select them. They're here. You're there. 3, 5, 7, blah, 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 11. That's looking pretty good. Now we need to add the axes labels, right? Nope.
No, that ain't it.
I use a Mac. Insert. Nope. Layout. Here we are. Axes titles. So here's the primary one. There it is. You just type right in there what it is. And then the other one. And then you can type in what that is. Okay? I would change these to different colors because blue and red, if you put in grayscale, are not gonna, they're not gonna look any different.
Make them both white.
So you can change them,
Good bro.
but you want to select the whole series, like I did not. There we go.
Oh. What?
Okay, and you ready to add in the standard error bars?
With what?
Okay, when you select them, you need to make sure they're all selected or it won't work. You see the error bars here? Layout ribbon has to be selected.
No.
More error bar options.
Is she?
And this one is what? Percent acyanogenic. So we're going to get all the way down to custom, specify values. And this is the positive and negative. So it's the part above the bar and the part below the bar on the top of the mean. So the positive is that part and then the negative is that part. So you need to select it for both. Specify value. And there's those for the first set. If they're really tiny, that's because, again, it was 0. And then you do the same thing for the other. One weird thing about this program is if you don't have the boxes out of the way, you cannot select them. I don't know why. It won't let you move it later. So there we are with our standard error bars. You have your clustered bar chart. And let's go back to our PowerPoint. And there's the screenshots of how to get to these things. Custom, you gotta click on those, that sort of thing. You guys with me?
What time is it?
3:30.
And it should look something like this when you're done.
I don't know why I didn't believe you.
And the last thing is the correlation. So we already have the data set up in
It's
here
like I said 3.
for correlation.
There's
That's
no
what
way
we
it's
made
past
the
I was thinking the good old bio lecture.
Hmm?
I was thinking the good old bio
that's
lecture.
when we have hardiness zone and acyanogenic and cyanogenic. That's what we needed for the correlations. And that we just did for the finding the means. Actually, I'm going to take that back. We're going to have to, where's my Excel file? We're going to have to copy and paste this. I spoke too fast. The hardiness, this time I just copy and paste it. To do the correlation, you want the hardiness zone, the percent acyanogenic, and the percent cyanogenic. So you're not just, we have a blank data sheet, data view. I'm going to paste it in there. Hardiness zone, acyan, cyan. So here's zone. Acyan. Sure I got that right. Yep. So for correlations, what kind of data do we have to have it coded as? Is this right? String and nominal? Scale. Which one of these? Yep. Numeric and scale for all of them. Then we can go to analyze, correlate, bivariate. We're going to do Pearson's correlation just like we did before. Let's do you think that so far by what you're seeing, if we look back at this, do you think there's going to be significant correlations or not?
Yeah.
Yeah?
Why not?
Are we going to do a one-tailed or two-tailed test? How do we know? What is our prediction? Is it in one direction? If we're looking at acyanogenesis, are we looking at one direction or is it both directions?
Both.
So as zone increases, are we predicting that acyanogenesis will decrease, increase, or both? As zone increases, is acyanogenesis going to increase, decrease, or both? So is it one or two-tailed?
One.
One? Here's our p-value, 0.001. And then remember Pearson's correlation, you report that as little r. So in this case it would be, and you need to keep the signs. So that means there's a negative correlation. That's what we were expecting, right? So negative 0.943. And then your p-value is actually exactly 0.001 for this. You'll do this again for cyanogenesis.
It's crazy, man.
But we're also going to visualize
example.
this. This is our last thing for data manipulation. Scatter
Come
plot.
on, I need to write my notes.
If we want to see how these data vary with one another, what is going to be on the x-axis? So the scatter plot. Zone is right. Acyanogenesis is what we just did. And look, it's pretty.
Gross.
That's a pretty good relationship, really. So, you'll obviously on your real graph, you're gonna want to double click this, make these more professional axes labels. Okay. And then what I would do is I would either
I always go.
type in like in a little. Once you've copy and pasted this into Word,
I didn't go
type
last week, that's it.
in
I was
either
gonna miss like half my
the
classes.
R and P value on the figure itself or in the figure
Not in the
caption.
mood.
Okay, but you'll be making two scatter plots, one showing the relationship between acyanogenesis and zone, and one showing the relationship between
I go to PPL last week
cyanogenesis and
either.
zone. I would call
So
this
we're going this
both like one big
Can't go
figure.
this
You'll
week.
have figure part A and B.
Or next week.
This will be your last
I probably shouldn't, but I have to.
thing that you'll probably show in your
I get kicked
report.
out.
And then you'll have your figure caption below it. Okay? So you can just add your A and B in using a text box in Word.
My battery's dying here, buddy.
Any questions on this? Yeah.
So would those